All right, now that we've covered some of the abnormalities that can occur, let's dive into some more detail of normal tooth development. Dentin is formed from the dental papilla, which is part of the tooth germ. The specific part of the tooth germ that generates dentin is the odontoblast. Once dentin is formed and mineralized, it is made of 45% hydroxyapatite. This is important to note because we will be comparing the mineralization of various tooth structures. The odontoblasts, or cells that make dentin, remain functional for the life of the tooth, meaning that you are constantly laying down dentin unless the odontoblasts become damaged. Predentin is what is originally secreted by the odontoblast. This is comprised of an organic matrix. Dentin is what the final product is referred to, and it's after the final mineral, or hydroxyapatite, is added. Another important point about dentin is that dentin and enamel occur via appositional growth, meaning they grow in opposite directions. Dentin begins forming adjacent to the enamel and deposits additional layers towards the pulp. All right, now let's look at enamel development. Enamel is secreted by ameloblasts. Ameloblasts originate from the enamel organ, specifically from the inner enamel epithelium. Enamel is made up of 96% hydroxyapatite, so we are able to note that this is more mineralized than dentin, meaning that it has a stronger structure and is more resistant than dentin. As mentioned previously, enamel also participates in appositional growth. The ameloblast begins secreting partially mineralized enamel directly adjacent to the dentin, and additional layers are deposited more coronally, creating a thicker layer of the crown. Ameloblasts differentiate after a few microns of dentin have been laid down by the odontoblasts. The partially mineralized enamel matures and becomes less porous over time as the mineral content also increases.
Now that we have finished talking about enamel, let's begin our discussion on cementum. Cementum comes from cementoblasts. We mentioned earlier that enamel comes from the enamel organ and dentin comes from the dental papilla, but cementum comes from the dental follicle. The dental follicle also gives rise to PDL and alveolar bone. With regards to cementum, the layer that is laid at the apex of the tooth is different from the cementum that is found coronally or near the top of the gingiva. Cementum at the roots of the tooth is cellular, and as cementum moves towards the portion of the tooth that is closest to the crown, it becomes acellular. This means it does not contain cells in its matrix. Moving on to alveolar bone. As mentioned previously, alveolar bone also comes from the dental follicle. Alveolar bone is specifically made by osteoblasts. Within the alveolar bone, there are a few different areas to know. First of all, the alveolus refers to the tooth socket. These alveoli are sockets in the jaw in which the roots of the teeth are held. Deep to that, the alveolar bone proper refers to the bone lining the tooth socket. Other terms synonymous with the alveolar bone proper are lamina dura and cribriform plate. Bundle bone is the inner lining of the alveolar bone where the PDL connects in. The PDL travels from the surface of the tooth through the alveolus and into the bundle bone of the alveolar bone. Deep to all of this is the supporting bone. The supporting bone is the cancellous or spongy bone that connects with the remaining structure of the mandible and maxilla.
Let's dive into the pulp. Pulp comes from cells that originally differentiate from the dental papilla. As you might remember, dentin also originates from the dental papilla. An important thing to note about the pulp would be that it has various zones. As mentioned before, odontoblasts move pulpally as they produce more dentin. The space between the dentin and the pulp is called the cell-free zone. Below that is the cell-rich zone, followed by the parietal neural plexus. All of this together is considered the odontogenic zone and makes up the most peripheral area of the pulp in the crown. There are two types of nerve fibers in the pulp. The two types of fibers are A delta fibers and C fibers. A delta fibers are myelinated. Because they are myelinated, they are associated with fast, sharp tooth pain. They are located in the coronal layer of the pulp and make up about 90% of the pulp nerve fibers. By contrast, C fibers are unmyelinated, meaning that they can be attributed to slow, dull, diffuse oral pain. As you might have noticed with both A delta and C fibers, pain is the main sensation perceived by these fibers and sent to the central nervous system.